Chapter 1. The Way of the Program. The goal of this book is to teach you to think like a computer scientist. This way of thinking combines some of the best features of mathematics, engineering, and natural science. Like mathematicians, computer scientists use formal languages to denote ideas, specifically computations. Like engineers, they design things, assembling components into systems and evaluating trade-offs among alternatives. Like scientists, they observe the behavior of complex systems, form hypotheses, and test predictions. The single most important skill for a computer scientist is problem solving. Problem solving means the ability to formulate problems, think creatively about solutions, and express a solution clearly and accurately. As it turns out, the process of learning to program is an excellent opportunity to practice problem solving skills. That's why this chapter is called The Way of the Program. On one level, you will be learning to program, a useful skill by itself. On another level, you will use programming as a means to an end. As we go along, that end will become clearer. Chapter 1.1. The Python Programming Language. The programming language you will be learning is Python. Python is an example of a high-level language. Other high-level languages you might have heard of are C, C++, Perl, and Java. As you might infer from the name, high-level language, there are also low-level languages, sometimes referred to as machine languages, or assembly languages. Loosely speaking, computers can only execute programs written in low-level languages. Thus, programs written in a high-level language have to be processed before they can run. This extra processing takes some time, which is a small disadvantage of high-level languages. But the advantages are enormous. First, it is much easier to program in a high-level language. Programs written in a high-level language take less time to write. They are shorter and easier to read, and they are more likely to be correct. Second, high-level languages are portable, meaning that they can run on different kinds of computers with few or no modifications. Low-level programs can run on only one kind of computer and have to be rewritten to run on another. Due to these advantages, almost all programs are written in high-level languages. Low-level languages are used only for a few specialized applications. Two kinds of programs process high-level languages into low-level languages: interpreters and compilers. An interpreter reads a high-level program and executes it, meaning that it does what the program says. It processes the program a little at a time, alternately reading lines and performing computations. A compiler reads the program and translates it completely before the program starts running. In this case, the high-level program is called the source code, and the translated program is called the object code or the executable. Once a program is compiled, you can execute it repeatedly without further translation. Python is considered an interpreted language because Python programs are run by an interpreter. There are two ways to use the interpreter: command line mode and script mode. In command line mode, you type Python programs and the interpreter prints the result. For example, here we have typed print 1 + 1. It returns a value of 2. The first line of this example is the command that starts the Python interpreter. The next two lines are messages from the interpreter. The third line starts with 3 greater than signs, which is the prompt the interpreter uses to indicate that it is ready. We typed print 1 + 1, and the interpreter replied 2. Alternatively, you can write a program in a file and use the interpreter to execute the contents of the file. Such a file is called a script. For example, we used a text editor to create a file named litoya.py with the following contents: print 1 + 1. By convention, files that contain Python programs have names that end with .py to execute the program. We have to tell the interpreter the name of the script. So we go to the interpreter and type python litoya.py, and it returns 2. In other development environments, the details of executing programs may differ. Also, most programs are more interesting than this one. Most of the examples in this book are executed on the command line. Working on the command line is convenient for program development and testing, because you can type programs and execute them immediately. Once you have a working program, you should store it in a script so you can execute or modify it in the future.